In this video, we ask whether it makes a difference if we run one model with multiple independent variables or multiple models with just one independent variable or many correlations. To start with the answer, yes, it absolutely makes a difference. Let's find out why. In a multiple regression model, there are several variables and a coefficient for each of them. For example, here we have age, gender, education, beauty and positivity. The coefficient for each variable tells us what else we will learn if we already know the other variables. So the question here is, if we know the age of a person, does this help us to understand why some people have more income or others less? But we've already taken into account the other variables, that the respondents are not all the same gender, etc. The question we're answering is, having already accounted for differences in gender, etc., that is, having accounted for the other variables in the model, does knowing the age help us understand the variance in the outcome? With correlations or separate regression models where there's only one predictor, we ignore those other variables, so the question we answer is different. Does knowing age help us understand the variance in the outcome? So we start with nothing as the baseline, whereas in the multiple regression model we start with all the other variables. In practice, the results can be very different, so this is not just a hypothetical question. My recommendation is always to make your life easier by putting what you've got on the table. Think about which variable is the predictor, the variable you're interested in, and think about which variables are control variables, the baseline so to speak. That way we know why each variable is in the model and we can avoid table 2 fallacy.